Today's lesson we are going to look at work, energy and power. Let us start. This chapter has 3 parts. As we can see, the topic it says work, energy and power. Today we are going to look at work, then lesson 102 of this chapter we are going to look at energy, and then the last lesson will be power. So today's lesson, the main goal is to know what is work, how do we calculate work, how do we calculate the work net or the net work, total work, how do we calculate a positive work, negative work, and then what is happening or what happens to the energy, specifically the kinetic energy when you look at the positive work and a negative work. Which forces does work to an object, which forces will not do work to the object. Before we actually start describing or talking about work in detail, you should know the following. Work is a scalar quantity. So it's another physical quantity. In this case, it's a scalar quantity, meaning that it doesn't have any direction. It only has magnitude. Keep that in mind or write these notes down. The second point that you should take note of work, it is measured in joules. Well, you are more than welcome to say it's some kind of energy, because we know that joule is an SI unit of energy. Like I said, we have a positive work and a negative work. These are some of the things that you should keep in mind when you talk about work. Now let us explain work in detail. What is work? Work is defined as the product of the force parallel to the movement of an object and the displacement of the object. Now let's say we have this object is being pushed or pulled this direction. Let's say it's been pushed this direction, and then this object's displacement is also this direction. Then we say the force that this person applies to the object does work to the object. Then how do we calculate the magnitude of that work? Remember, we said work is a scalar quantity. It doesn't have any direction but only magnitude. So how do we calculate that magnitude? We are going to use this equation. W is equals to F, that force that does work to the object, multiplied by its displacement, multiplied by cos theta. Now explaining this in detail, this is the work measured in joules, and then this will be our force measured in newtons. This will be the displacement, which is measured in meters, and then this angle is the angle between the displacement and that force, which we say it does work to the object. To relate this scenario to our previous points that we talked about, I'm referring to these points, this one and this one. Just know that as this person is pushing this object to this direction, I mean to the right, and then the object is moving to the right, we know that we have this other force which will be opposite to the motion of the object, which is our kinetic friction. Now between the two forces, this force will do a positive work to the object, and then you should know that kinetic friction will do the negative work to the object. Then for the positive work, just know that kinetic energy is increasing, and then for the negative, kinetic energy is decreasing. We know that our common forces, we have Fg, which is our gravitational force, we have our normal force, Then we can say this is our force applied from the previous example, and then the opposite force will be the kinetic friction. Now the first question, how many forces does work to this object? The first one, oh, by the way, the displacement of the object is actually this direction. Let me write it here. So how many forces does work to the object? Now the first one, which is our force applied, it does work to the object. And you should know that the angle between the force applied and the displacement is actually 0. Why do we say it's 0? Let us understand this. This is our force applied. And then this is our displacement. We can see that the displacement and the force, the angle between the two is actually 0. Then we know that cos 0 is equals to 1. In this part of this chapter or this lesson video, I'm trying to explain how many forces does work to the object. Let us go to the second one. Let us take a look at our work done by normal force. Know that this will be our normal force. Displacement cos, let us figure out the angle between the displacement and the normal force. So if we put our normal force here, you can see that the angle between the displacement and the normal force is actually 90 degrees. So if we put 90 degrees here, we know that cos 90 is equals to 0. And then 0 multiplied by this, it will give us 0. Then we can see that normal force does no work to the object. Or we can say the magnitude of the work done by the normal force is 0. Our next force, let us talk about kinetic friction, work done by kinetic friction. You know this will be kinetic friction, and then let us figure out the angle. This is our kinetic friction, and then from the displacement to the kinetic friction, we can see this angle is 180 degrees, meaning that we have 180 degrees here. Now we know that 180 degrees is equals to -1. So we have Fk changing x, and then this will be -1. Then this will result into negative Fk changing x. So now you can see the reason why we say we have positive work and negative work. Since kinetic friction will give us a negative work, we say its kinetic energy is going down. Kinetic energy, which comes from the work done by force applied, will go up. So you can see the reason why we have a negative. It actually comes from the angle of our displacement and kinetic friction. Looking at the last force, which is force done by gravitational force, well, looking at the angle, if this is our gravitational force, looking at the angle, we can say the angle is 270. Now we know that 270 cos 270 is actually 0. So we have Fg is equals to Fg changing x, we are going to have 0, and then everything will be 0. then it means work done by Fg is actually 0 joules. I hope you understand this. So basically two forces which does work to the object, which is kinetic friction and our force applied. Looking at the two, we can conclude then we said this is our displacement. Then we can conclude that the force that does work to the object must be parallel to the displacement of the object. Doesn't matter whether displacement is, the direction of the force is to the left or right, as long as it's parallel to the displacement, then we can say the two forces, or that force, does work to the object. Suppose we have this scenario. A man pushes a box, 220 newtons is applied to the box by the man. The box and the surface experiences the kinetic friction of 40 newtons. The mass of the box is 50 kg, and then the displacement of the object is 10 meters to the right. So this is the displacement. Now the first question, calculate the work done by the force applied. The second question, the work done by the normal force. The third question, work done by kinetic friction. Question number 4, calculate the net work done on an object. Question number 5, the net force. Question number 6, work done by the net force. For you to check whether you understand this concept, you may pause the video, work out the questions, and then play the video to verify your answers. Now the first question, it says calculate the work done by the force applied. This will be our number 1. We are going to take the force applied multiplied by the displacement cos, know that it's cos 0. So force applied is 220 multiplied by 10, or displacement is 10, cos 0. So we know that cos 0 will be equals to 1. We get that our work done by force applied is 2200 joules. I hope you got this one correct. For our number 2, it's work done by normal force. Changing displacement cos, we know that it's cos 90. But let us actually fix this. Start by writing the equation the way it is and put that theta. Also this one, let me quickly rectify here, put theta here. Then the next step, we can substitute. We know that normal force is mg, so our mass is 50, and then we have 9.8. We have 10 cos 90. Well, we don't have to punch this down. We know that cos 90 is equals to 0. So 0 multiplied by everything, it will give us 0 joules. I hope you got this one correct also. For question number 3, work done by kinetic friction is Fk changing x cos theta. Then we have our Fk is 40, displacement is 10, we have cos 180 degrees, which will give us -1. So punching this on the calculator, we're going to have -400 joules. That is the work done by kinetic friction. Then number 4 is the work done by the net. Actually, we're calculating the work net. So to find the net work net, we are going to take the sum of all the work done by all the forces onto the object. So basically we know that normal force and Fg, they do no work, it's 0, so we might as well take the sum of the two, which is the work done by the force applied plus work done by our kinetic friction. This will give us 2200 minus, or let me say plus, minus 400. Then this will give us positive 1800 joules. So this is the work net. I hope you got this one correct also. Then question number 5, it says calculate the net force acting on the object. So to calculate the net force, looking at the diagram quickly, we know that Fg and normal force in terms of magnitude they are equal but opposite direction, so their magnitudes will cancel each other, but we can work it out on the equation. So we have force applied plus normal force, we take up as positive, right as positive, minus Fg minus Fk. So our force applied is 220 plus normal force, we have the mass, which is 50 multiplied by 9.8 minus 50, 9.8 minus 40. So you can see that this and this will actually cancel each other or minus each other. So we have 220 minus 40, which will give us 180 newtons. That is our net force. Looking at question number 6. Question number 6 is the work done on the box by the net force. So we are going to find the work done by the net force, which we are going to take the net force as our force, displacement, and then cos the angle. Net force, we found that it's 180 newtons, so we are going to substitute here. Displacement is still 10, cos 0 degrees. We get that our work done by the net force is 1800 joules. So this is our answer. Now for the first part, or the first lesson of work, it ends here. The next lesson video we are going to look at work, lesson 102, where we look at more complicated situations. There is a worksheet based on today's lesson that will go hand in hand with this lesson video. Now that's it for this lesson video. This is Babula SJ. Thank you very much.